Hello, everyone. In this video, I want to share two methods of point cloud filtering with you. Point cloud filtering, in the whole point cloud data processing, occupies a quite important role. It not only serves to produce digital elevation models, contour lines, but is also the basis for subsequent point cloud classification. Point cloud filtering is also known colloquially as ground point classification. Two filtering methods are described in this talk. An evolutionary encryption filtering method called classical irregular triangulation network. The second filtering method is an improved progressive encryption filtering method of irregular triangulation network. The two methods have the same framework, but the basic units of processing are not the same. The basic unit of the first process is a point, and the basic unit of the second process is an object. Let's take a closer look at these two approaches. Of course, we have referenced a lot of articles in the making of this video. These three articles are more representative. For those who are interested, you can focus on reading these articles. Especially in the second and third articles. The two filtering methods involved in this lecture are described in detail. However, TIN encryption is a very classic filtering method. It does not require a particularly large number of parameters, and the principle is relatively simple. What are its approximate steps? First of all, the point cloud of the entire survey area is divided into regular grids. The size of this grid often corresponds to the largest building size within this area. After the regular grid is divided, we select the lowest point within each grid as the seed point for the ground point. The seed points of the lowest points corresponding to all the grids are then grouped together. We can use these seed points to generate an initial, coarse irregular TIN of survey areas. This irregular TIN itself is 2.5-dimensional, and represents a very rough digital elevation model of the area. Then the next important step is to iterate the discrimination. Two important parameters were used in the discrimination. One is called the iteration angle, and the other is called the iteration distance. In addition, in order to better add the ground point of the terrain breaks to our irregular triangulation network, such a threshold called the terrain inclination angle is also added. In combination with this figure, let's take a closer look at the relevant parameters. The red dots in FIG represent the initial seed dots for this area. And the blue dots represent other potential ground points that are not identified. In Figure 2, we see two parameters. One is the vertical distance from the unidentified point to the plane of the triangle. And the other is the maximum angle between the unidentified point and the three vertices of the triangle. Then this distance and angle correspond to the iteration angle and iteration distance in the figure above. At the same time, this mirror point is related to this topographic inclination in the above figure. Its purpose is to add the ground points at the terrain breaks to our irregular TIN so that these points can be judged as ground points as much as possible. The following animation roughly illustrates the process of progressive encryption of the entire irregular TIN network. First of all, we divide the point cloud of the entire survey area regularly, select the lowest point in each grid as the seed point, and build the initial irregular triangular network. Then, you iterate constantly, encrypting these ground points. Let more ground points join this irregular TIN until stable. There are two indicators of this stability. One is that the number of iterations has reached an upper limit. Another is that no new points are recognized as ground points. As we can see by the following profile, it is easy to make a detailed distinction between ground and non-ground points using the filtering method of progressive encryption with an irregular TIN. Our software also integrates this classic irregular TIN progressive encryption filtering method. This filtering method is just one of our filtering methods. For those who are interested, you can try it. The second key method is the filtering method of irregular TIN progressive encryption algorithm based on object primitives recommended in our software. Compared with the previous filtering method, this filtering method uses the same filtering framework, but the difference is that the basic unit it handles is no longer a point. Instead, they are objects of planar or smooth surfaces that come from a typical segmentation algorithm called surface segmentation. At the same time, in order to speed up the calculation, we also introduced the edge points and keys of the object. Replace the entire object with these keys and edge points to participate in the operation. What's the benefit of this? It is to reduce the calculation time and improve efficiency. In our software, the irregular TIN progressive encryption filtering method based on object primitives is placed in industry application modules for UAV. This is also the filtering method we recommend. Well, in this video, we briefly introduced the principle of the filtering method. If you are interested in the details of the filtering algorithm, you can refer to the above related articles. Thank you. You can contact us by email at jonas_zank@gmail.com or WeChat at +86 13888837 1238. Alternatively, you can obtain a trial license by filling out the relevant information on the website https://www.thjymap.com/pca. Thank you for watching and see you next time.